Hello. I'm doing this video to help you solve a variable expression with many variables or variable equation and a variable equation with many variables for one particular variable. So we're going to kind of ignore most of the variables and just treat them kind of like they're numbers. And then we're just going to focus on like one particular letter to solve for that letter. Okay. All right, let's see a problem. Okay, it says solve the equation for the requested variable. N, they want us to solve for N. So we have this, so where is the N? So there's the N, and I'm just gonna treat all these like they were numbers, I guess. Like I'm just not focused on those other letters. Usually when we have an equation, there's one letter in the equation and we have to solve for that one letter. It's usually X. But here we have lots of letters. So we're just going to pretend like they're numbers and solve them exactly as if they were numbers. And the only letter in our mind, or the only one we really want to solve for, is the N. So just like when we have the equation like 3x equals 12, we have something, or we have the variable we want to solve for, and we have something in front of it or being multiplied to it, then the natural thing to do, and you have to remember, as we always do in this situation, is we do the opposite of multiplying our x by 3, because we're currently multiplying the x by 3. We do the opposite, we divide by 3, and doing a fraction bar and putting the 3 underneath, it means division. So we have x is equal to 4. That's our final answer here. So in this situation, we have n times this stuff. We have the same situation. Here we have our variable we want times by something. We just divide by that something. And here it's a big chunk of something, but still we're multiplying by a lot of stuff. So we need to divide by all that stuff. And that's kind of weird. You know, whoa, we're just gonna divide by all that stuff. And I just continue keeping it in parentheses. And then I just divide by it on the other side as well. If I do the left side, do the right side, there we go. So that's our answer for this first part. We're going to make sure for entry purposes, you have to put what is in your numerator in parentheses, then divide in parentheses what's in your denominator, and that's we're done with that first part. Okay. Second part is a little bit more difficult. They want us to solve for G. They want us to solve for G. So this is our original expression. So I need to get rid of whatever we are multiplying the G by. So I divide both sides by N. And I get WG plus V, because these N's are going to cancel because it's a factor. N is a factor of the numerator and a factor and in the denominator. And the only thing in the denominator, so we're able to cancel the N's on this side. And then on the other side, we have Q plus U over N. Okay, then now I'm still focused on getting that G isolated by itself. So we're taking G and we're multiplying by G and then adding to G. So first we always, if we're taking G and adding to G, and if it's not in parentheses, we would subtract by V on both sides. So I get WG is equal to Q plus U over n minus v on this left side. And then we only have to do one more thing. We have to divide by this w. You have to focus. G is the one we're trying to isolate on one side of the equation. So we just divide by G here on both sides of the equation. Sorry, W divided by W, because we now the W's are going to cancel. I'm going to get G on this left side, which is exactly what I wanted to get. Isolate G by itself. When they say solve for G, that means isolate G by itself using algebraic expression, algebraic, moves, valid algebraic moves. And now the only problem is in this numerator, I have all this stuff, and then it's all being divided by W. So this is why in this class, I spent so much time in the beginning of the class reviewing how to add, divide, and multiply fractions, because now here we need to do it. We need to, and this is something very important. When I have two terms in the numerator and I'm dividing by something in the denominator, I have to divide both this term and that term by the W. Okay. If you want to think about it in this way, when I have, two terms, I think about it as I have two separate suitcases. And we'll call this one the first term. And here's the little suitcase handle. And then we have a second term. Who knows how big it is? We don't know how big these are because we don't know how big the variables are, but whatever. I have a q plus u over n variable, and I have a v variable, okay? And we'll say just a negative v, we'll just say that. And we'll just think, because it's actually subtracting v, whatever, we won't notice that too much. It's not important here, too much. Okay, let's say this is a scale, right? It's on a scale. If I wanted to take this and cut this in half, this whole weight, all the weight on the scale, if I want to cut it in half, can I only just cut, the one baggage in half? Is that going to cut all the weight in half? No, right? And that's what some of you guys do. You guys think, oh, all I have to do is do q plus u over n divided by w. You just do this division here, and you don't do this division over here. Okay, so we need to kind of remember that I have two packages of unknown weight. If I want to take each of them and divide, and in my example, just in half, or that's dividing by 2, but we're dividing by whatever w is, which is, if we have to divide both of those in half. If I want to cut all of the weight on that scale in half, both of those need to be cut in half. Okay, so we just have to remember that image when we are doing these problems. Okay, and then this is going to be a hard calculation, because now we have to do q plus u over n. That's a fractional expression divided by, I'm going to make it even a bigger fraction bar, so it's that fraction bar divided by this. And then we also have to do, I'm going to make this into, well, we could do minus if we want to, or plus a negative v. I'm just going to I'm going to keep the negative sign in with the v and make it into addition problem. So this is what we call complex fraction. It's kind of hard to simplify if you don't know how to simplify regular fractions. Hi, Marshawn. Hi, Marshawn.
Hey, Professor.
I'm making this video for another student really fast. I'm just gonna, I have like two more steps, I think, and then I'm all done. Is that okay?
That's fine. I'll listen in.
Okay. All right. Good. I was explaining with this problem, you're trying to solve this expression for G. We have this original expression as WG equals Q plus U over N, or wait, no. this was the original expression. Well, and then we were trying to solve it for g. So I said we have to divide by n, and then we have to subtract v, then we have to divide by w on both sides. But then we have this fraction where we have to divide by w. So this is now a complex fraction. This is q plus u over n, that fraction, divided by w. Now, instead of, I can't really, when I was working with whole numbers as well, and just regular numbers and regular fractions, I could not divide by, I divide like a whole number and a fraction. I have to turn every whole number into a fraction. So I can do w over 1. Now I have this fraction divided by that fraction, and I have to remember k, f, c. I keep the first fraction the same. Q plus u over n. And then now I flip the second fraction, or find the reciprocal of the second fraction. So it's 1 over u. And then the c is for change. So I change the division to multiplication. And I just have to, it's just process, but this expression, and I have to put that in parentheses here, I have a binomial times by something, I would have to times that number by everything in the binomial. It's not really that important here because we're multiplying by 1, and whatever you multiply by 1 by is just going to be itself, right? So it's q plus u, and then on the bottom it's going to be n times w. So n times w. So that's what we get when we're done dividing and simplifying this part. Is I get everything simplifies to be q plus u divided by n, that time n w, n over w. Okay, so that is that one little portion, and that's why we reviewed fractions and how to divide fractions, because we're going to need it here. So that all simplified to be q plus u all over nw. Okay, now our issue probably, and I'm thinking that they want us to simplify. Usually, I mean, we technically at this moment, we have solved for g. Technically, they like to usually have it more simplified than the way it's looking right here. See, I'm like having 2 addition of fractions, and it's just a mess. It's just simply put, it's a mess. So what I would do is I would like a common denominator between these 2 fractions. And I would notice how I have an n times w here, and this one just has a w. So it makes sense to me if I just multiplied, if I want a common denominator, if I want these denominators to be the same, I have to multiply this denominator by n. So both on the top and on the bottom, right? So I'm going to get negative vn in the numerator and over wn. And I have to stop here, and I have to say, okay, some kids they'll literally multiply it by n, and they'll be like, oh, well, now I can cancel the n. Well, no, that we multiplied by n so that we could get the same denominator, so that we could add these fractions together, not so that we could just recancel it immediately. All right, sometimes we lose focus of what we were really doing in the first place, and that really destroys things that we're like, how do we do this now? Okay, so now I rewrote negative v over w. That's actually equal to negative vn over wn, or nw. So it's commutative property, we can. Okay, so then now I can add these things together, g plus u, or q plus u over nw, and now I can add the numerators together, and it's minus vn, all in this numerator. So that's our final answer here. Q plus U, just I added this numerator plus this numerator, or I actually ended up subtracting, right? Minus Vn all over Nw. And that's our final answer. And we can double check it here. Q plus U minus Vn over Nw. And this one was just the original one. All right. I hope that that made a lot of sense to you guys. And anyways, just email me if you have questions. Bye.